y equals negative 3 times the quantity of x minus 5 squared plus 9. First of all, we want to find the turning point. Well, once again, change the sign, keep the sign. Change the sign so it's going to become positive 5. Keep the sign, 9. There's our new turning point or vertex. A in this problem is negative 3. And because that value is negative, it means that this point is going to be a maximum. The equation of our axis of symmetry, the formula, which I didn't talk about in the last video, is x equals h. And this value of 5 is h and 9 is k. And remember, we're really picky about the x equals. So this is going to be x equals 5. To find the y-intercept, what we're going to do is we're going to put 0 back into that equation wherever we see x. So in fact, what we can do is we can take out our calculator and we can just type in negative 3 parentheses 0 minus 5 squared plus 9, and that's going to give us our y-intercept of negative 66. It's going to be 0, negative 66. Our domain, just like problem number 1, is here. Our range. Well, if we start here, let's get the vertex on here. It's 1, 2, 3, 4, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 5, 9. And then we can go 1 to the right and 1, 2, 3 down. And then to the right 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You could type this one in your calculator. But here's a rough sketch of the picture. And what we see here is that the range, it goes from the lowest value to the highest value. So it's going to be negative infinity. And our highest y value on this graph is up here at 9. Well, in this one, it says find the zeros of the function. So I was trying to avoid typing in the calculator, but we're going to have to type it in anyway. So let's go to y equals, and let's type in our function. Negative 3 times x minus 5 squared plus 9. And we can check my picture. There it is. But what we can see on here is that our x-intercepts, which are our zeros or our roots, aren't whole numbers. So what we're going to have to do is we're going to have to do second, trace, and 0. And then I'm going to go left. But I'm using the right button here because everything is to the right of the y-axis. It just takes a while to get where I need to be. There we can see a cursor. So somewhere to the left here, I'm going to hit enter. To the right, and enter, and enter. So we get, it says round to the nearest hundredth, so it's 3.267, so we're going to write down 3.27 as one of our roots. And then comma, and then let's do that one more time. So second, trace, 0, still using the right hand button. Little bit to the left, enter. Little bit to the right, enter, and enter. And don't get confused here when you see this negative 3.3 e to the negative 12. That's just a number in scientific notation. And it's 0.0000, a bunch of zeros before the 3. So we're really going to have our other 0 here, which is 6.73 when we round to the nearest hundredth, which is 2 decimal places. When we go ahead and put this equation in standard form, actually before we put it in standard form, the transformations here, and the first one is the negative out here in front. When there's a negative out in front, that means that our graph is going to reflect over the x-axis. Also out in front is the 3. But notice that I'm listing them separately because the negative does something and then the 3 does something, which is it vertically stretches the graph. Then we have minus 5 inside the parentheses, so we're going to go right 5. And then we also have the plus 9 outside the parentheses, which is going to be the up 9. Which I hope that when you're finding the turning point or the vertex that you're able to identify those pieces from there. When we convert this equation into the other form, here back in from vertex form, which is how it's written, negative 3 times x minus 5 squared plus 9. What we're going to do is it's going to be y equals negative 3 times x minus 5 times x minus 5 plus 9. And what I'm recommending to you is that you multiply these two first with double distributive property or with FOIL, whichever one works for you. So I'm going to leave that negative 3 out here, and then it's going to become x squared minus 5x minus 5x plus 25 plus 9. Well, we can combine like terms or we can just distribute. It's not going to make that much difference. If we distribute, we get negative 3x squared plus 15x plus 15x plus, nope, minus 75. Negative times positive is negative, plus 9. And now here, when we combine our like terms, we still have y equals negative 3x squared plus 30x, the 15x plus the 15x. And then lastly, we've got minus 75 plus 9, which should give us minus 66. And this is the standard form. And plus it makes sense too if we go back and check our y-intercept, 0c, sure enough, there's the 0, negative 66.